Okay, good morning everyone. So myself Devabroto Kumar Das from Tumka Engineering College. Today we will take the subject is process instrument control. And today we will discuss the continued topics in our flow measurement.
Okay, good morning, everyone. Am I audible?
Yes, sir.
Okay. So let's start. So we have discussed in our last classes, this is our measurement part in our process control industries. This is flow measurement. Okay. And this part it is also continuing. This is the flow measurement. So last classes, we have discussed different categories in our flow measurement method. So what is the flow measurement? What is the method we have to use the flow measurement? So just recall some idea of the flow measurement, then we have to continue our next another topic. So this measurement of flow rate and quantity, it is the basically oldest of all measurement of the process variable in the field of process instrumentation. Okay, so this flow measurement you have to control. This is our uses for some steam flow control. Some it is also called water or some liquid type of control, and also gaseous type of service we have to done by this flow measurement method. So without this flow measurement, the plant material, it is not balancing or any quantity or quality control without this flow control method. So this flow measurement, it is made both for fluid as well as also solid also. Okay. Next, we have to discuss what is the method of the flow measurement method. So last classes we have discussed this flow measurement method. It is basically categories into three categories. First one is inferential type flow meter. Number two is quantity flow meter and also mass flow meter. So we have started first one, that is the inferential flow parameter. So in this inferential flow parameters, there are lots of measuring units or measuring methods we have to discuss. This is variable head or differential meter, variable area meter, magnetic meter, turbine meter, target meter. Okay, so just we have to explain. This is the basically inferential flow measurement. And in this inferential flow parameter or flow measurement, it has different method, that is the variable head or differential meters. Number two, that is a V, variable area meter. Number C is the magnetic meter. Number D is the turbine meter. Target meter. Number F, thermal flow meter. Next, this is the vortex meter. And last, that is the ultrasonic flow meter. So these are the categories in the inferential type of flow measurement. Okay. So in this inferential type flow parameters, flow measurement, we have to classify these different categories. This is the variable head or differential meters. We have discussed in last classes also these variable type or variable head or differential type of meters. Then we have to discuss that is the variable area meters, magnetic meters, turbine meters, target meters. Okay, this is the thermal flow meters, vortex meters, and also ultrasonic flow meters. So these are the basic categories of the inferential type of flow per measurement. And last, we have to also discuss according to our diagram. This is the variable head type or differential meters also. And also in this category, we have to discuss there are lots of different flow parameters. Okay, so there are different parts it is available in these differential meters. This is orifice plates, venturi tubes, flow nozzle, tull tubes, elbow taps, or ANUVA tubes. So these are the different categories it is coming in our differential meters. Okay, so next we have to start first one, that is the orifice plate. Network. So sorry for that, little bit here, my here network problem. So this is the classes again cut. So we have continued. So this is the orifice plate, okay? This orifice plate, it is coming in our flow measurement part. So this orifice plate, this is the basically simplest and cheapest method we have to use in our primary elements for the flow measurement method. Okay, so this is simplest and cheapest form of primary element and are used more frequently than all other types. Okay, so this orifice plate is inserted in the line and the differential pressure across it is measured. Okay, so this orifice plate, it is the basically simplest and cheapest method for the flow measurement techniques. So this primary element and are used more frequently than other types of flow measurement method. We have discussed in previous classes, there are lots of process or lots of parameter we have to uses for our industrial purpose for the flow measurement method. So first, this is the orifice plate, then venturi tube, then dial tube, then another elbow taps, ANOVA tubes, wear and types gauges, meters, so etc. So these are the different procedure we have to use this for our industrial purpose for the flow measurement method. But in this method, we have to broadly used or widely used. This is the orifice plate method. So this orifice plate, it is inserted in the line of the differential pressure across it is measured. So this orifice plate, you have to use a different type of pressure of the internal of the flow measurement of the tubes. So sometimes it is also uses higher pressure and also as low as low pressure. So according to their parameter, we have to classify this orifice plate into four categories. Okay. So this orifice plate is classified into four categories. Number one, this is concentric orifice plate. Number two, eccentric orifice plate. Number three, segmental orifice plate. And number four, quadrant edge orifice plate. Okay. So these are the basic category. We have to classify this orifice plate into the different pressure gauge, different pressure method, or different pressure positions. We have to use this orifice plate. So first one, this is the concentric orifice plate, then eccentric orifice plate. Number three is the segmental orifice plate, and also number four, quadrant edge type of orifice plate. So next, we have to also discuss one by one what is the basic structure of the different orifice plate. Okay. Up to this part, it is clear. Please respond me. Up to this part, it is clear or
Yes,
not?
sir.
Okay. So we can go next. This is the different structure or different diagram of the different orifice plate. Just wait. I am drawing one by one, so please everyone see that. Okay, so this is the basically first concentric type. Anyone, any questions? Or otherwise, please mute yourself. First, I am drawing, and again, then one by one we have to discuss. Okay, so you have to draw in your exercise book. So every diameter, these are the basically circular space. Okay, so in our whiteboard, this is little bit also not circulate, not circular is proper position. So please ignore it. This is the eccentric type. Another one, this is the segmental type. This is the half circle. Okay, this one. Segmental type. And last one, this is quadrant edge type. This is the quadrant edge. Okay, so this is the basically different figures of the different types of orifice plate. Okay, so first one you can see this is the basically concentric type. Okay, so this is the basically concentric type. Here you can see this is the basically one circular hole, and this is the basically open area. And this type of orifice plate we have to install in our constant flowing the pipe in the inlet or outlet patterns also. Okay, so and here you can see this is the another one. This is the eccentric, and in this eccentric type of orifice plate, the hole it is basically present in the lower part of the orifice plate also. Okay, then also this is the another third one. This is the segmental type of orifice plate. This segmental type of orifice plate here the circle it is also half circle. Okay, this is the segment type. So that's why this is called the segmental type of orifice plate. And this is the basically quadrant edge type. Okay, this is the basically quadrant edge type of orifice plate. This is the basically holes, and these are the basically another one also parameter we have to also changes according to our uh, diameter. Okay, according to our flow diameter, we have to change it. So that's why this is called the quadrant edge type of orifice plate also. Is it okay? Please respond me. Is it okay or not?
Okay, yes, sir.
So please, yeah, thanks, Saurabh Suman. Please, everyone present in the class, uh, because all of you, please respond, please. Okay. Otherwise, I am not understand all of you this topic it is clear or not. And today the present is very low. Only uh, 6 students are joining. So please, everyone, tell your friends to join the class because it is basically recorded, and also the attendance is also only given in the entire the session you have to present whoever. Okay, okay, next next we have to continue. These are the different types of parameters. So first we have to discuss the concentric type of parameters. Concentric orifice plate. So this concentric orifice plate, it is basically used mostly in our process control industries in the flow measurement method. So it is basically made by the stainless steel. So it is most widely used and it is made of stainless steel. Stainless steel. And the thickness is varies from different ranges are available from 3.175 millimeter to 12.70 millimeter. So these are the different ranges. We have to make the concentric type of orifice plate, and it is made by the metal, that is a stainless type of metal. And it is basically this is dependent. Basically, this diameter is depending on pipeline size and flow velocity. This is very important. So according to this parameter, that means the pipeline size and also flow velocity, you have to choose the different ranges. That is the range is 3.175 millimeter to 12.70 millimeter. Okay, and it is a circular hole. We have also discussed in last, that is a constant. This is basically circular hole. So this circular hole in the middle part, it is basically installed in the pipeline. Okay, and with the hole is concentric to the pipe also. So this is basically one plate type, and this is the inner hole. And this inner hole you have to connect it the pipeline side. Okay, so it is also made from the other materials, that is we have to use another material, that is nickel. 1 minute. So another material we have to use this in this concentric type, used for concentric type. This is the nickel monil type of metal, monil metal, or phosphor bronze. Phosphor bronze. So these are the basically MCQ part questions you have to follow. So which metal you have to use as in the orifice plate or concentric type of orifice plate. So according to the plate thickness, we have to use the orifice plate in the different diameter. So we have to calculate the diameter, that is a d by 50, and also sometimes it is also expressed, that is small d by 8. So this is basically d minus d by 8, where d is the internal diameter of the pipe. So that means the pipe internal diameter. Small d, it is the orifice diameter or bore. Sometimes it is also called bore. So what is it? So this is a basically one formula, that is a one expression, that is a d by 50. So here this d is the basically pipe size. That means you have to use different pipe sizes. So this d is the express here the internal pipe diameter also. Okay, and this small d, this is the basically uses for the orifice diameter. That means what type of orifice plate you have to use. That is here you have to classify it in the concentric type. So this is the basically diameter. It is expressed here small d, that is d by 8 also. So according to the format, according to the pipe sizes of the flow capacity or pipeline sizes, we have to express here T minus capital T minus small d divided by 8. Okay, so these are the basically required expressions of the concentric type of flow parameters. Then eccentric type. This eccentric type, it is also another one. A previous diagram you have to see here also one circular hole we have to present, and this circular hole we have to attach in the pipe. Okay, so it is similar to the concentric type of the Orifice plate, and also in this concentric with the pipeline size or diameter, it is equal to the near about 98%. Okay, and also this orifice plate we have to uses in the solid flow parameters, solids as well as also water as well as also oil or different stream. So this eccentric type of orifice plate we have to classify it. It is basically similar to the concentric type, but here little bit it is a difference here. So the inner circle, it is present in the lower part of the orifice plate also. So this eccentric type flow parameters, you have to use as different fluids, or there are different types of solids or different types of oil, etc. Or sometimes it is also uses the weight type of stream flow parameters also. Okay, and this is basically made for the material of the stainless steel or tungsten type of materials also. Okay, so this is the eccentric type. Orifice. Next one is the segmental type. So this segmental type orifice plate, it is the same type of the service to the other types, but here you can see the hole, it is also present the half circles. Okay, so this half circles, so in this diameter, it is basically it has a hole which is segment of the circle, and this diameter which is the customizedly we have to customize the 98% of the pipe diameter. So it is installed with the dam horizontal and with the curved sections of the coincident surface type of parameters. So this is the basically uses we have to use this in broadly pressures, that where the higher pressure is available. That means dam, where the water it is we have to store for a long time. So that means here the water pressure, it is huge pressures. So these huge or increased type of pressures, we have to control the flow measurement using this segmental type of orifice plate. Okay, and this is also horizontally connected to the flow measurement part also. Then also another one is the word and edge type of orifice plate. So this basically this type of orifice plate we have to uses different chemical industry or different where medical industry, where the cup syrup, that is a different types of syrups are mixing or measurement, or heavy crudes, that is a crude oil. This crude oil we have to make from the petroleum industries also. Okay, or some slurry type of flow parameters, and also viscous type of flow we have to use this quadrant type of edge parameters. Okay, so it's Reynolds number. We have to discuss in our previous classes the Reynolds number. What is Reynolds number? Anyone please tell me? I am discussing previous classes. What is Reynolds number? What is the expression of Reynolds number? Reynolds number we have to express, that is the RD. This is equals to V D rho by mu, where RD is the Reynolds number, V is the average velocity of the fluid flow, D is the capital D is the inside pipe diameter, rho is the density of the which type of fluid you have to use this for the flow, and mu is the absolute viscosity. So this is the basically Reynolds number we have to know. Okay, so this Reynolds number, so in this quadrant H type of flow parameter, the Reynolds number, it is basically ranges, that is a 3000 to 500 at the ratio. Okay, so we have to know there is no unit of the Reynolds number. Okay, so this is the value, only value we have to consider here. So here the value is the quadrant type of H parameter. This is the 3000 to 5000 Reynolds numbers we have to consider for here. So these are the basically different categories we have to use this in our process control industry. Next, what is the advantage? Why you have to use this orifice plate? So advantage of orifice plate. Okay. Number one, it is low cost. Number two, they can be used in a wide range of pipe size. This is the 3.175 millimeter to 12 point, not 12 point. This is the basically another one. 1828 to 8 millimeter type. This is the overall. That is the fourth type of orifice plate we have to discuss here. So this is the basically different pipe size we have to use this in our process control industry. This is the 3.175 millimeter to 1828 millimeters. Number three, they can be used with differential pressure device. Okay, so this orifice plate we have to use this different types of
हाँ चलिए ना
yes Ravi Kumar,
चैट
any
में आना
question?
अभी नहीं ठीक एवरीवन है खाली नाम मेरा लिख दे रहे
Ravi, please mute yourself. Okay, so everyone please write your own name and roll number in the chat box also. And Saurabh, are you hearing me?
Yes, sir.
You take a screenshot and after ending the class you have to send me. Okay.
Okay, sir.
Okay, number four, they are well known. And have predictable characteristics also. And last one, this is they are available in the different types of materials. Available in many materials. So these are the basic advantage. So its cost is very low. So that's why we have to mostly use in our process control industries. They can be used in a wide range of pipe sizes. This is the basically diameter of the internal pipe size, that is a 3.175 millimeter to 1828.8 millimeters. And it is also uses different type of pressure devices, and it's predictable. That is this is basically uses that the accuracy level is very fine. So that's why we have to use it in the Orifice Plate. There is a predictable characteristics, and they are available in the many materials. That is, sometimes it is also made for the stainless steel, and also some nickel or some phosphor type of bronze, and also tungsten. Okay, and what is the basic disadvantage? Disadvantage is also coming in our Orifice Plate also. This is basically a little bit. Sometimes it is also changes characteristics in the different corrosion. This is the disadvantage. That is the corrosion. That means that sometimes it is also corrosive type of materials. Okay, corrosive type of materials you have to follow. You have to going in this inside diameter. So this is the basically certain type of error, corrosion, erosion. Okay, so these are the basically certain little bit of disadvantage. And it's basically sometimes it is also different result in the different another types of, that is clock type of material, or any solid type, that is a slurry type of material. Sometimes it is also basically disadvantage. We have to follow the what it is flow parameter. And little bit also disturbing, it is a different humidity of area, that is the environment structure. It is certain disadvantage that we have to follow. Okay, so this is clear, all of you. So this is the Orifice Plate. Next class we have to discuss Venturi tube. This is another important materials we have to use in our flow measurement methods. So anyone any questions, so please ask me. And I uploaded that the class note in the Google Classroom, so everyone